All right, guys.
Hello there.
Welcome to Geometry.
This is 6.2a.
Performing reflections. You ready?
Let's go.
It's Lego.
Example 1. Graph reflections in horizontal and vertical lines. So the vertices of triangle ABC are A is 1, 2, B is 3, 0, and C is 5, 3. Graph the reflection of triangle ABC described. So we are graphing the reflection over the line x equals 2. Well, first things first, let's graph our points. So I'm going to graph point A over 1 up 2, point B over 3 up 0, point C right 5 up 3, and I'm going to connect those to make my triangle. So we know it's going to be a triangle because of this right here. It says triangle ABC. So now we are going to graph this reflection over the line of x equals 2. Well, what is x equals 2? What kind of a line is that? Well, x equals 2 is a vertical line at 2. So that means we find our 2 on the x-axis and we draw the line up and down because x is 2 on that line every single time. That's something you might remember from Algebra 1. So I'm going to draw in this vertical line at x equals 2. So that is my line I'm going to be reflecting over. So now, what do we do next? We are going to reflect each point of this triangle over this line, okay? I am going to start by reflecting point A. So how do I reflect point A? What I'm going to do is I'm going to count the spaces that it is away from my line of reflection. This is my line of reflection, okay? So point A, and you can see what I did with the purple marker there, point A is 1 space away from the line x equals 2. So that means when I graph the reflection, it's going to be 1 space away on the opposite side of the line. So I drew 1 space away, and now I'm going to fill in my new point, A prime. Don't forget that the reflection points have that prime notation. So that point is now A prime. Okay, I'm going to now do point B over here. So I need to count how many spaces away that B is from this red line. So point B is 1 space away. So its reflection will be 1 space away. And I'm going to fill in point B prime. Okay, and last but not least, I'm going to reflect point C. How many spaces away from the line of reflection is point C? Well, point C is 1, 2, 3 spaces away on the right side. So I'm going to go 1, 2, 3 spaces away on the left side and fill in C prime. Now I have all 3 of my points. I'm going to connect them to form my original triangle, and I have reflected this triangle over the line x equals 2. So what are the coordinates of my new points? Well, point A prime is over 3 up 2. Point B prime is right 1 up 0, and point C prime is left 1 and up 3. So basically what this looks like is if I took this coordinate plane, this whole thing, and acted like it was a piece of paper, and I folded this piece of paper over this line, each of the dark green points would reflect where the light green points now are. And that is how you reflect across a vertical x equals line.
What a great explanation, Mr. Lulo. Well, example 1 says the vertices triangle A, B, and C need to be graphed as a reflection over the line of y equals 3. So I always like to write down all of my coordinates in a faster speed, A, B, and C, just to pull them from the problem. And I would then highlight the fact that it's going to be that shape, which is a triangle, is going to be graphed and reflected about that line. So here's A, B, and C. Looking pretty good, connecting all my points and my vertices. Okay, so we have a y equals 3 line, And you have to think whenever a lot of you guys get really confused of if this is going to be a horizontal or a vertical line. Well, y always has to equal 3 in a line. So if you pick any point in the line, the y value has to be 3. So this is going to be a horizontal line at 3. I don't know why that was drawn so quickly, but you guys get the point. All right. So when you are trying to find the other coordinates for a prime, b prime, c prime, you're basically counting to the line. So if you want to look at just a, okay, a is 1 point away from the line. So then you just go in the opposite direction, 1 away. Boom. That's where a prime would be. Okay. Do the same thing with b. B is about 1, 2, 3. And then in the opposite direction, 1, 2, and 3, b prime would go right about there. Okay? And then same thing with c, except c is right on the line, so we don't have to go anywhere. C would be the same, c prime would be the same exact coordinate. So let's do this. There's a prime, and then b prime, and then c prime, which is right where it originally was, because it's right on the reflection line. Connecting all my vertices, and just to clarify what my coordinates are, a prime, b prime, and c prime. There you go.